Okay, this is sort of a quick problem where we solve this word problem, which is an optimization problem. And what we're trying to do is optimize area given that there is a constraint. And so let's read through the problem. A farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a straight river. She needs no fence along the river. What are the dimensions of the field that has the largest area? Well, what we're going to do is write down a formula, which is a formula for what we're trying to find the optimal amount, and that is area equals xy. So we're trying to find x and y that give the maximum area. Now, if there was no constraint, you would just make this enclosure bigger and bigger and bigger. But she does not need any fencing along the river. Now, what I've done is I've drawn a rectangle, but it's not quite a rectangle. It has only 3 of the sides. And I'm labeling the horizontal x and the vertical sides as y. And that's the length of those. Now, the constraint is there's only 2,400 feet of fencing. Now, if we're talking about perimeter, which is, a formula that a lot of people are used to, the perimeter would be of a rectangle would be 2 times the width. The perimeter would be 2 times the length plus 2 times the width. So perimeter, which I feel like I should erase in a moment, is 2x plus 2y. That's the perimeter. Okay? So I'm relating this because maybe you've seen that formula before. But this is not perimeter because of a rectangle. You could say it's perimeter of this enclosure, but this time there's only 1x, even though there's 2y again. And that x plus 2y is going to equal the entire amount of the fencing, which is 2,400. I put little boxes so that we could fill in. So it's not 2x plus 2y is 2,400. It's x plus 2y is 2,400. I'm going to now erase this perimeter formula there. Just trying to relate that to that. Now, A is a function of x and y. We want to find x and y, which makes A area a maximum. Let's see. So this is area. All right. And what I'm going to do is I'm going to eliminate one of the variables. You can eliminate either one. If I solve for x and then eliminate the x, I will not have a fraction. You might want to eliminate the y, but then you get a fraction. But either way, most people can do something with fractions, but sometimes it's a little easier if you don't have the fraction. So what I do is I write a is xy, and I replace x by negative 2y plus 2,400. And what I see now is I have a formula for area that depends on y. Now, I suppose it wouldn't be such a bad idea for me to write down the domain of this. Y should be greater than 0, and it should be less than, when x is 0, we would get 2y is 2,400, so therefore 1,200. Now, even though we don't really want y to equal 0 or y to equals 1,200, you can just put that there by continuity. Okay, so let me go that more carefully. Y, it could be 0. Then it could be y could be very small, and then the whole thing would be really wide. X would be large, and you'd have really small y. On the other hand, x could be really small. Say x is close to 0. When x is 0, when x is 0, 0 plus 2y is 2,400. So 2y 2,400 makes y 1,200. It's not even clear that I really need to write this down. Now, one thing I can notice is that this formula, a equals negative 2y squared plus 2,400y, is, if I were to graph it, would give a parabola. And the maximum of that parabola is at the vertex. So therefore, you could just solve this problem by finding the vertex. And this is a problem often you see in a pre-calc book for that reason. But what we're going to do is we're going to use calculus and find that maximum by finding a critical number. The critical number is going to be where the derivative is equal to 0 because, I mean, by definition of what a critical number is. And that's going to give us where we have a horizontal tangent line. And because I know it's a downward facing parabola, that will be a max. How do I know it's a downward facing parabola? Because parabola, it's a equals negative 2y squared plus 2400y. That negative 2y squared, the y squared means parabola, negative 2 means facing down. The derivative is, of that guy is super easy to find compared to other things we've done. I suppose nothing is all that easy in calculus, but relatively speaking. So we get y is 600 feet. That is going to give the maximum area, as y is 600 feet. And after that, and I'm saying it's a maximum because a equals negative 2y squared plus 2400y when I sketch the graph is a downward facing parabola. So y is 600 would be the maximum value, the value where a is maximum, y is 600. Now to find where, it doesn't ask us to do in the problem, but to find where the second coordinate where I have the maximum would be plug in y is 600 and then find a. We can do that later. Let's find x first though. So to find x, we have, we're going to use again that x plus 2y is equal to 2400. So I have x plus 2 times 600 equals 2400. These numbers are all fairly easy, I think, to work with. I mean, we do have zeros here, but otherwise it's pretty straightforward. Now, if I did want to find the area, I could just multiply 1200 times 600, which isn't that, you can do it sort of in your head if you know your times table. 6 times 12 is 72. So it'd be 72 with 4 zeros. What is that? 720,000. So those are the dimensions, and it sort of matches the picture I've drawn there. And again, if you wanted to find the A, which would give the second coordinate at that point where there's a vertex, you could multiply 600 times 1200 and get 720,000. Or you can just put y as 600 into our a equals negative 2y squared plus 2400y. Maybe the whole thing, my video wasn't as good because I sort of kept the question a little bit obscured during that. But again, you have a farmer. The farmer might be raising corn and red tomatoes, berries, or something, and the construction and the fencing is to keep the animals out so they don't eat that. But either way, this is a classic problem along the river. You don't need a fence. Maybe it's a barn. You don't need a fence along the barn. So you have a three-sided enclosure like that. And the maximum area is when I have that the vertical is 600 and the horizontal is 1200. Okay, so that's that. Okay, take care. Bye.